Final example in this section, let's see how we're going to calculate probabilities now using our calculator. So the number of chocolate chips in that should be 18-ounce bags of Chips Ahoy cookies is approximately normal. I'm going to highlight that because that's a keyword. With a mean of 1,262 chips and a standard deviation of 118. And then the cadets of the U.S. Air Force Academy figured that out. So we want to know what is the probability that a randomly selected 18-ounce bag contains between 1,000 and 1,400 chocolate chips inclusive. Okay, so inclusive means including those values. Okay, so we can draw a quick picture of what's going on. Really quick sketch. I won't worry about the mean or the standard deviation or inflection points. But we have 1,000 here and 1,400 here. And again, probability is area. Probability is area. So we have to find the area between these two values, and then that area will be the probability. How do we find the area under a normal curve? We use normal CDF. Make sure you do not use PDF. You want to use CDF. And this is always area under a normal curve. And I'll write that too because we're still learning. Area under a normal curve is our normal CDF function. Okay, so our parameters is the lower bound, which is 1,000, and then upper bound, our mean, and our standard deviation. Sorry, normal curve. Okay, so we plug that into our calculator like I showed you in the previous video. And we can go out to 4 decimals. So we could say that the probability is 0.8657. All right, let's look at our next example. What is the probability? Again, probability is area, that a bag contains fewer than 1,000 chocolate chips. All right, so if this was a discrete random variable, and we know it's not because it says it's normally distributed. So if it was not normally distributed, if this is a discrete variable like a binomial random variable, we would have to translate fewer than 1,000 chips, so less than or equal to 999. But because it's normally distributed, we don't care about that. Because if we just take away the 1,000 value, we know the probability of a single value is 0. We saw that in at the beginning of section 7.2. So because it's normal, that means it's continuous. It means we can just write 1,000. We don't have to think of 999. All right, so fewer than 1,000 chips means area to the left. All right, and remember, this goes to negative infinity. So minus a really big number. How we write negative infinity in our class is -1 times 10 to the 99th. All right, and we saw in our calculator video how we do that. Okay, so normal CDF, because that's area under a normal curve. Lower bound, negative infinity. Upper bound now is 1,000. We always read it left to right. And then mean, standard deviation, and those are commas. All right, so put that into your calculator, and we get 0.0132. All right, part C, what proportion of a bag contains more than 1,200 chocolate chips? Well, again, proportion we know is area. So we're still finding the area under a normal curve. Now it's more than 1,200. Okay, so more than 1,200 All right, so again, we're starting at 1200 for reasons we've already discussed. And more than means area to the right. So again, more than, we're going to the right. So we have to look at the corresponding area for that interval. All right, so now our lower bound, what's the smallest number? It's 1200. What's the biggest number we go to? Well, we go to infinity. So we're going to write that in this class as 1 times 10 to the 99th. That's 1 with 99 zeros. All right, so put that into our calculator. Make sure we're all getting the same thing. And we're getting 0.7004. All right, let's look at part D. We're looking at percentile rank. Remember what percentile is? Percentile is area to the left. So when we say percentile, that's equivalent to area to the left. All right, so again, we can do a quick little sketch to help establish our upper bound and lower bound. So the smallest number would be that negative infinity. So that's going to be your lower bound. So normal CDF is area under a normal curve. We're starting at negative infinity. Negative infinity would always be a lower bound. Positive infinity would always be an upper bound, if you like to make those types of distinctions. Upper bound is 1475. Next comes the mean and the standard deviation. Okay, so this ends up being 0.9645. How do we say that as the nearest percentile? We could say the 96th percentile. All right. Part E, determine the number of chocolate chips in a bag that make up the middle 99%. Okay, so notice here we have to find the values of the variable, and we're given the area, all right? So we're using a different calculator function. So let's draw a picture. So we want to get the middle 99%. Oops, hopefully yours is a little bit more symmetrical than mine. So we have to find two values. We can call them x1 and x2, and those are going to be chocolate chips. So when we have area and we're finding values, we have to use inverse norm. And if you remember, your parameters are area to the left. I'll just draw a left arrow. And then the mean and the standard deviation. Okay, so we have to figure out the areas to the left. So first let's figure out what's in these tails. So if this is the middle 99%, just figuring out areas to the left, we know there's 0.01 left over, and then it's equally divided amongst the tails. So this is 0.005. Likewise, this area is 0.005. Then everything adds up to 1. Okay, so our first value, x1, inverse norm because we're given area to the left and we want to find the value. Area to the left is 0.005. We have our mean and our standard deviation. And we put that in our calculator. And we can round to the nearest chocolate chip. So we could say 958 chocolate chips starts that middle 99%. And then x2, well, area to the left of x2, you can think of it in two ways. Either You can do 1 minus 0.005, because that would be the opposite. Or area to the left of x2, it could be 0.99 plus 0.005. And then we end up with 0.995. Then we have our mean, standard deviation. So plug that into our calculator, and we get 1,566 chocolate chips. So the number of chocolate chips in a bag that make up the middle 99% is 958 and 1,566 chocolate chips.